Welcome back, Algebra 2 students. We are going to talk about advanced substitution. And this is substitution within our uniform motion problems. That would be our dirt problems where the distance equals the rate times the time. And when we have equal distances, rate times time equals rate times time, right? The distance is the same as this distance. Our first problem is going to have a uniform distance. The second problem is going to have uniform motion. So let's we're just going to jump right into the first one so you can see what I mean. Typically, we are given the values of three of our variables, and that helps us find the missing fourth one. That's not going to happen here. Instead, we're going to be given four equations that we have to associate with one another and use what we know about algebra to suss out those four variable values. So let's just jump in. All right, in this problem, A says that RW times TW is equal to 6. And the second equation is that RB times TB is also equal to 6. So you can see they have the same distance. It's 6 miles or 6 feet or whatever it is, but they both equal 6. So that's good. That gives us a relationship there. C tells us that RB is equal to 3 times RW. And then we are told that D is that TB is equal to 2 minus TW. All right, so we have four equations, and what we're going to do is we are going to find values that we can substitute in for others. So we're given the value of RB, and we're given the value of TB. So let's drop that into this equation and see if we can go ahead and solve for some of it. So RB is 3 times RW times, so that's RB. Now TB, this is the value of TB, 2 minus TW. So 2 minus TW. That's TB, and that is equal to 6. So as you can see, we use a different color. This was RB, and this is the value of TB, and they are times each other. So that's how we drop that in, right? That's our original equation right there. All right, let's go ahead and solve this out by distributing the 3RW to what's inside the parentheses. So that's going to be 6RW minus 3RW times TW equals 6. Well, we are told that RW times TW is 6. So we can take this value and substitute it in here. So 6 times RW minus 3 times the value of RWTW is 6, so we can put 6 right in there. That equals 6. So 6 times RW minus 18 is equal to 6. So we're going to add 18 to both sides. So 6 RW is 24. All right, I'm going to go ahead and write these up here. RW is equal to TW is equal to, RB is equal to, and TB is equal to. So if I divide 24 by 6, then I get that RW is equal to 4. All right, so that lets me solve for TW, because if RW is 4, then I can say 4 times TW is equal to 6, right? That's this equation. So all I have to do is divide both sides by 4, and I get that TW is equal to 3 over 2. Because I can write it like this. This is being divided by 4, so 6 over 4 reduces to 3 over 2. So TW is 3 over 2. Easy peasy. All right, so now that I know what TW is, I can find out what TB is, okay? So I'm going to take this formula and I'm going to solve by putting in TB equals 2 minus 3 over 2. Okay, so 2, this is 2 over 1. So in order to have a common denominator, I've got to double this, right? So that would be 4 over 2 if I double it. So I'm going to rewrite that. Here, TB is equal to 4 over 2 minus 3 over 2, which is going to equal 1 over 2. So TB is equal to 1/2. Now that I know what TB is, I can solve for RB. So RB times 1 over 2 is equal to 6. Right? So how do we get rid of a fraction? So first let's write this the right way. 1/2 times RB. What do we do to get rid of a fraction with a variable? We multiply both sides by the inverse. Right? So times 2 over 1. We put this over 1. So 2 times 1 is 2. 1 times 2 is 2. 2 over 2 is going to be the invisible 1. So RB is equal to 12 over 1, which is just 12. So RB is equal to 12. And that is the final solution. We have all 4 of our variables solved for. And we really just had to do one that was complicated. The rest of them were pretty simple after that. So if you haven't written all of this down, go ahead and do so. All right, and then I am going to, there's another thing that we could have done where it says 3RW here. Well, never mind. That was RB. RB was that. That's what we used to sub in. All right. Miss Tracy's just jumping at ghosts and shadows, so just ignore that. Let's move on to 65.2. Clear the page. 65.2. And here are our 4 equations that we're going to do, that we're going to solve. We have, first of all, A is equal to RP times TP, and that is 693. Okay, so let's look at B. B says that RC times TC is equal to 165. So we can tell right away that these are not uniform distance. They might be uniform motion, but they are not the same distance at all. So let's look at C. It tells us that RP is equal to 3C. So that's similar to what we had before. I'm sorry, not 3C, 3RC. That's better. And D is TP plus TC is equal to 12. So first things first, I've already got RP solved. Or not solve, but I know the value of RP, it equals 3 times the RC. So I want to solve for TP so I can drop that value in as well. So I'm going to subtract TC from both sides. Okay, this cancels. That leaves me TP is equal to 12 minus TC. Okay, so now I have a value for TP and I have a value for RP that I can multiply against each other. So RP is 3RC. So 3RC, all right, that's that one, times, and TP is 12 minus TC. So 12 minus TC. That's what we're doing right here. It's this formula, RP times TP. This is RP is equal to this, and TP is equal to this. Now I finish the formula with what's given to me, 693. Now I'm going to distribute, so 36 times RC, that's 3 times 12 is 36, minus 3 times RC times TC equals 693. Well, RC times TC is given to us. It's 165. So I can rewrite this and say 36 times RC minus 3 times 165 equals 693. I can't do that in my head, so I'm going to pull up the calculator, and I'm going to say 3 times 165 is 495. So this is minus 495, and this is 36 RC. All right, so I'm going to add this to both sides. And that's going to be 36 RC is equal to 1188. No, I'm not that smart. Miss Tracy has already worked this problem once to make sure she could do it right. But I am going to use my calculator and divide 1188 by 36. Because 36 times whatever this is equals this. So I'm going to undo that by dividing. 1188 divided by 36 is equal to 33. So RC is equal to 33. So I'm going to go ahead and start. I'm going to say RC is equal to 33. TC is equal to something. RP is equal to something. And TP is equal to something. Right? So now that I have RC, I can solve for TC. So if RC is 33, then bring that one down, and I can say 33 for RC times TC is equal to 165. So all I have to do is get on here and divide by 33 on both sides. 165 divided by 33 is equal to 5. So TC is equal to 5. All right, so now I can solve for TP. TP is equal to 12 minus 5. TP is equal to 7. So now that I have that, I can solve for RP. All right, so RP times TP, which is 7, equals 693. So all I have to do is divide 693 by 7, 99. RP is equal to 99. Now the other thing you could have done was you could have said RC is 33. 3 times 33 would have still given you 99. So you could have used RC to solve for RP this way as well. So RP was equal to 3 times 33 because it was 3 times RC, and that's what RC is. Same solution either way you do it. So that's an indicator that if you can do it both ways and get the same number, you're probably right. And that would be our solution set for 65.2. All right, awesome. That is all we have for lesson 65. I will see you ladies in 66. And if you have any questions, especially those of you who are new to the class this semester, please message me or text me, and I will dig deeper. I'll send you a little bit more information so you can understand how to solve these types of problems. And that's all I have for now.